Okay, good evening, everybody, and welcome to this evening's presentation, which is with Laughlan Steer. And Laughlan's going to be talking to us about renewable energy. This is the latest in a series of articles and blogs and seminars that he's done and talks. So without any further ado, I shall hand the floor over to Mr. Steer. Laughlan, please take it away.
Thanks very much, Julie. Well, good evening, welcome everybody. I must confess, this is a bit of a novel method for me. I'm more used to larger rooms and people face to face, but we will continue and be as resilient as we can in the present circumstances. So I would ask to forgive the lockdown beard and slightly scraggly hair, but hopefully the shirt makes up for that with a bit of bright print for these uncertain, or should I say, unprecedented times. So a bit about me. I started client side before I became a solicitor in the rail and energy sectors. And that's where I kind of got my interest really for energy and infrastructure, and particularly the renewables project that the guys were involved with. I then trained with Charles Russell Speechlys, and there were some big projects there, both renewable and more traditional, here and overseas as well. And then moved to Silver Shamings Ash about 3.5 years ago. And I've got to say, it's been a privilege working on innovative projects. We've got some interesting clients in the renewables sphere, and of course, some of the London landmarks as well. So what's on the agenda today? Well, I'll be doing a roundup of my article series, expanding on some of the areas there for further discussion with some updates and new figures for this year. I'll be looking at the circular economy and how this interfaces with the renewables market, and potentially what we have been doing, what we could be doing better as well. And a look at where we are now in the context of the present COVID-19 crisis. And at the end, there'll be time for a few questions if you have them as well. So as a firm, we've become more involved in renewables projects, and it's an area that we, and me particularly, are very passionate about. It's clearly, without doubt, hugely important for the planet that we take this seriously, and we do our best to see what we can do and innovate in the industry without sounding too David Attenborough about this. There is definitely a climate emergency. And there's also the more legal, interesting aspect of the interaction with the Construction Act, and of course, carve out for energy generation, and the misunderstanding and general lack of knowledge that we've encountered there as well. But that is a topic for another time. So before I recap some of the more popular forms of renewable energy generation, it's probably worth taking a look at the traditional energy generation methods and have a brief comment on those before we look at the renewables side. So of course, renewables are distinct from fossil fuels, including coal, natural gas, and crude oil, and then of course separately nuclear as well. Of course, crude oil has been in the news recently. The total value wipeout for the West Texas futures contract 2 days ago, with barrels now trading at below $0 per barrel. So I think that's really emblematic of the turbulence that we're all facing now. So nuclear, of course, is again different from fossil fuels in the sense that although it's low carbon and the energy that itself is renewable as a source, of course, the material used in nuclear power plants is not. Nuclear accounts for about 10% of the world's power, and of course suffers from a few downsides in that there's the general public fear and the sector costs, which are of course set to rise, no doubt in line with safety concerns across the various projects. There's also, of course, the lead time issue, i.e. how long it's actually going to take to get one of these plants up and running. And this is a factor in these sort of power generation projects that we will pick up on later. This delay is a common issue. So it's probably worth just noting the paradigm shift really in power consumption in this country, which will give a nice backdrop to today's talk. So by way of example, in 2010, Britain generated 75% of its electricity through coal and natural gas. In 2019, this figure had reduced to only 2%. Now, that is a monumental difference within a decade in anyone's book. And I mentioned natural gas earlier, which remains still substantially more popular than coal-based power generation. And this is an interesting topic, really, because it is discussed as a lower carbon alternative to coal-fired power generation. And it's touted as a solution, a bridge solution, some might say, i.e., well, whilst we're on the way to a renewable solution, this will tide us over. But that proposition requires potentially a bit more examination. So people will be quick to say that new natural gas plants, which are efficient, will be 50% less in carbon emissions than traditional coal-fired plant. This is a good bit of spin, frankly, in that it's not always going to be enough to achieve emissions goals to say that. Now, why is that? Well, on a sort of wider perspective, there are several issues at play here, many of which are conveniently ignored for the purposes of touting natural gas as a bridge solution, as I've said. So these will be the huge carbon emissions during extraction, of course, during the construction of the infrastructure itself, and the transport and storage of natural gas. Now, this leakage from extraction and transportation, otherwise known as fugitive emissions, studies have said that it could account for up to 9% of the project's life cycle emissions. Now, 9%, you might think that doesn't sound a great deal, but there is a bit of an issue here. And the issue is that to be carbon competitive with coal-fired plants, the project's leakage needs to be below 3.2%. Otherwise, you end up with a station plant that's actually worse for the environment. So if we take this a step further, then, and we consider this against the effect of methane emissions from natural gas plants, well, there's another big issue here, and that is that methane is around 100 times more potent as an insulator than carbon dioxide, at least for the first 20 years or so that it's in the atmosphere. So therefore, if there is a small amount more over the 3.2% that I've just stated there, if there's more leakage than that, then there are grave consequences for the resulting global warming implications. And frankly, we shouldn't necessarily be bothering if that is the key driving point, rather than simply demand for power. I do feel, though, that methane is potentially getting a bit of a bad rap here, though. And there is one crumb of comfort, well, sort of. Methane persists for much less time in the atmosphere than carbon dioxide. By contrast, it's estimated that 15% of today's CO2 will still be in our atmosphere in 10,000 years' time. So some food for thought there, certainly. So I mentioned the phrase potent insulator, and some of you may recall my talk from the Future of Construction conference back in September, where I discussed emissions and in particular the Thwaites Glacier. So for those that weren't there or simply don't recall, I think a little brief recap now could be in order. So the target of the Paris Agreement in 2015 was to reduce global warming to well below 2 degrees Celsius. Unfortunately, without further drastic action, experts are currently predicting that the world is on track to hit 3 degrees within 80 years. Now, 1 degree, you may not think there's too much to worry about there, but this would lead to certain catastrophe. One of the most serious consequences of this level of global warming would be the rising sea levels caused by the melting of the polar ice caps. And it's estimated that 80% of people living in Asia would be affected in some way by this geological disaster. So onto the Thwaites Glacier. And this is a patch of frozen water in Antarctica, the size of Florida, that's already begun to destabilize. And experts have described the potential flood damage caused by the total collapse of the glacier as incalculable, so fairly concerning. It already accounts solely for 4% of the annual global rise in sea levels. So that is very much an area to look out for and quite concerning. It's vitally important, therefore, that we focus on green forms of power generation. And that leads me nicely on to some examples below, which I'll discuss, and some commentary there as well. So wind, first of all, is an intermittent form of energy generation, and it harnesses the power of wind to drive a propeller, which in turn generates electricity. These can be placed onshore or offshore, and in 2019, wind power contributed 21% of all electricity generated in the UK, which surpassed both coal and nuclear power generation. Now, as an island nation, we are ideally placed to generate energy from wind. Some commentators have suggested we are the best placed in Europe to do so. However, despite increasing our energy output in wind by around 500% since 2009, we're still, and I would say perhaps understandably so, a long way behind the two behemoths at the top of the league table, which are China and the USA. More on them later. We do have some bragging rights though, and we're soon to boast the largest wind turbines in the world. And this is in relation to the Dogger Bank wind farm, where onshore cabling construction began in January. These are turbines which are located off the coast of Yorkshire in the North Sea, and the individual turbines stand almost 900 feet tall, with blades extending over 350 feet. The other countries set to benefit from this installation include Norway, the Netherlands, Germany, Denmark, and Belgium. So another renewable form of power generation would be geothermal. And to enable this form of power generation, wells are drilled into natural fissures in areas of shallow but high temperature water to capture that boiling water or steam that flows up. Now, naturally, the viability of this source of power is going to be incredibly location dependent. We'll come on to the areas and the countries that are leading this in a bit. So the plants that benefit from these geothermal wells generate power by using steam to drive a turbine or water to boil steam separators, which then turbines. And binary geothermal plants can employ both methods, injecting the condensed steam and other fluids back into the fissure to heat up further. One downside, apart from the obvious geographical restrictions, is the likelihood of polluting the local water supply, which is obviously a bit of an issue and runs somewhat contrary to the aims of renewable power generation. In terms of the global leaders, well, it's more glory for the USA, I'm afraid. The world's largest producer of geothermal power in 2019, and the proud owners of the largest geothermal development in the world. The geysers, or as our American friends would say, geysers, just north of San Francisco in California. Second and third places belong to Indonesia and the Philippines, respectively. Iceland, of course, famed for its hot springs, actually resides in 9th place. So the next form of power generation I'd like to briefly touch on is hydroelectric or hydropower. So these plants represent a cheap, low emission way of producing a substantial amount of power. And they take the form usually either of a dam or a mid-river plant. In either case, the water flows through the tunnels, turning turbines to produce electricity. Now, they're not without a downside, however, and the amount of land required for construction often results, unfortunately, in population displacement, and inconsistencies in downstream flow of water can impact agriculture and industry. One example of a contentious hydropower plant is, of course, the Kishanganga Dam, which 7 years, in fact, before commissioning, became the subject of a tense arbitration between India and Pakistan relating to land ownership and rights to water flow. Good work for the lawyers that got that, no doubt. Interestingly, and focusing back in the UK, we've actually had hydroelectric power for over 140 years. This was in fact first harnessed in 1878 to power the lights of Cragside Country House in Northumberland. And in the UK, Scotland and Wales are popular locations for hydropower installations, albeit that actually overall, as a renewable source, it accounts for only 2% of our total electricity supply. Preeminent nations for hydropower generation include, surprise, surprise, China again, the USA again, but also Brazil, Canada, and Russia, which perhaps isn't that surprising. Overall, hydropower is the world's #1 renewable energy source, accounting for nearly 20% of the total electricity generated globally. So now on to solar power. And of course, there are two technologies, preeminent technologies that sit there: photovoltaic systems, or PV systems, and concentrated solar power, CSP. You would tend to hear more about PV systems in the press. And there have been some interesting innovations actually very recently, which we'll touch on very briefly in a bit. So the way these work, PV systems absorb the sun's energy with the semiconductor PV cells, and these are assembled in a modular fashion to produce the panels that you will have seen. Following exposure to sunlight, a direct current is formed across the panel's layers, which is then converted to an alternating current for export into the grid or residential or commercial use. CSP, concentrated solar power, on the other hand, utilizes reflective surfaces to concentrate sunlight and uses the accrued heat to power steam-driven turbines. Due to the reduced production costs of PV panels, this method of power has increased in popularity, with the average cost of PV kit reducing by about 50% in the last decade. Notable investments in this sector, of course, include Elon Musk's Solar City, which is one of the subsidiaries of Tesla. Now, the innovation that I just mentioned, it took place in China at the start of the year, where two companies have unveiled 500-watt panels in PV capacity. Now, these are therefore 30% more powerful than the average panel. I suppose the downside being, due to their size, these things are quite large, the obvious reduction in handling and installation costs is probably not going to be reflected in the uptake in the domestic market, because they're simply too large for most houses to use. But great innovation there nonetheless. So on now to biomass and waste. And energy generation from either biomass or waste provides a cleaner alternative to fossil fuel power generation, whilst at the same time addressing the overuse of landfill. So biomass energy can be derived from a variety of organic matter. To list just a few, you could have wood, corn, nutshells, sugarcane, grass, manure, and sewage. So it's quite a broad categorization as a feedstock or fuel. Now, direct combustion of this organic matter is the simplest way of exploiting the available energy. Other methods for generating power from biomass include pyrolysis and anaerobic digestion, or AD, more on that later, both of which involve the degradation of matter without oxygen. There are some issues, of course, and crop-based biofuel has recently faced criticism due to the environmental and social impact of replanting areas to accommodate the source of fuel. And would you believe it, the USA and China once again reign supreme in the biomass installed capacity stakes, with the UK coming in 5th place, behind only Germany and Europe, so a reasonable showing from us there. Well, what about the waste element, I hear you say? Well, we have the Germans to thank as the original innovators in this field. And what happened was, in the 50s, they burned tyres as a replacement for fossil fuels, kickstarting a movement known as the alternative fuels movement. Now, one of these, refuse-derived fuel, or RDF, is comprised of combustible waste like plastic, which would otherwise be sent to landfill. And since its adoption, this has enabled millions of tons of Britain's waste to be used as a renewable energy source. This has led to the somewhat perverse scenario where landfill is seen nowadays as more renewable than, say, wood. And we've been fairly strong on the uptake in Britain. In the last 30 years, our adoption of refuse-derived fuels in preference to fossil fuels has increased more than tenfold. And the way that this works is the waste is processed prior to becoming a fuel, taking the form of either a shredded mixture or a compressed item like a pellet or a log. And that is then burnt in combustion facilities to produce electricity. Interestingly, it can also be used in cement kilns, and if sufficiently clean, can be commoditized by way of unused carbon credits sold via a carbon exchange. Now, you'd have thought with such a broad categorization as refuse-derived fuel, there would be some overarching legal definition, or at least I would anyway, but there isn't. That being said, Germany is sort of leading the way in Europe on that, so perhaps more to follow from them. Now, negatives, again, threats from the public perception. The public are generally concerned on these potential sites of AD plants about emissions and noise. Of course, we all know it's referred to as NIMBYism, and that is shared with many other renewable power generation projects like onshore wind. You know, people are quite happy to have them off the coast potentially, but they don't want them in their backyard. Now, of course, the impact of Brexit on the above is not really known as of yet. And in particular with RDF, there's quite a currently relaxed waste trading setup between EU states. And one concern in this industry is that that could be disrupted by our departure. Indeed, after the implementation of the landfill directive, continental Europe has seen a substantial investment in energy from waste plants, and there is a substantial demand for refuse-derived fuel, some of which came from Britain. Hopefully, even if we are precluded from trading this in Europe, we'll be able to increase our domestic usage and therefore continue to battle the landfill situation that we find ourselves in. So, in terms of our need to continue the battle, and the demand for renewable fuels. Well, that is an interesting topic, and I think as a population globally, certainly in most areas, which is growing and growing, energy demand is of course increasing too. So we need to explore solutions that satisfy both the environmental and economic interests. So while your average person may well be more sustainably minded, whether they're prepared to pay a premium for these products or services remains to be seen. That being said, the rise of companies like Octopus Energy that offer 100% renewable tariffs would suggest so, but then again, they do have the benefit of Octopus Renewables, one of their group companies, which is the largest investor in solar power in Europe. But well done them nonetheless. So I suppose we should celebrate the fact that low carbon electricity accounted for more than 50% of our energy last year in Britain. It's not good news across the board though, and this is where we go back to talk about nuclear briefly. And it's unfortunate that our beleaguered network of nuclear plants has suffered a series of outages in the last decade, significantly impacting progress in this area. And the downside of that is any shortfalls, of course, in nuclear electricity generation are likely to be replaced by traditional fossil fuel power stations. What's more, the 8 plants which provide about 20% of our electricity supply are unlikely to be replaced anytime soon. This is further compounded by the fact that Hitachi pulled out of 2 sites last year, hot on the heels of Toshiba's departure from the proposed 3 gigawatt plant at Moorside. Now, this is concerning for 2 reasons. Firstly, these abandoned sites would have accounted for 15% of the UK's electricity demand. And secondly, all bar 1 of our current nuclear plants are due to go offline by 2030. We're therefore looking at a substantial energy deficit in the years to come. One little crumb of comfort though, I was very amused when I was doing my research to come across some scientists, I believe in Northern Ireland, who'd ascertained how to convert waste barley from the brewing process into activated carbon and carbon nanotubes. And given that the industry is discarding millions of tons of unused grain each year, this represents a very welcome finding. I wonder if this can be of assistance in the likely huge waste process that we're going to see for the pubs, which of course are shut currently, and the breweries too. So how does this process work, these mad scientists in Northern Ireland? Well, it's a 2-stage chemical process required to facilitate this transformation. It's inexpensive, and this is good because the demand, of course, remains ever high. It's an excellent example of a circular economy whereby waste is turned into a product of value. And of course, the ramifications of this cycle are wider still, addressing both the global waste and energy crises. Hopefully then there'll be more innovation on a similar line in different fields, because I think all of this is very much we need to be considering as to these low carbon solutions and renewable solutions for the future. So I mentioned the phrase circular economy. And what is our potential then for achieving this, or indeed potentially a more circular economy? Well, I think systems that produce energy from waste have an obvious role in the generation of a circular economy. This will enable a departure really from the current linear system where materials are produced, used and disposed of, if we can then actually use more of the so-called waste items. So returning then to anaerobic digestion, where say food waste can be converted to biogas. This leaves a digestate which can be used as a fertilizer in agriculture. That is a very obvious way then of linking energy generation into food production within this circular system. There's actually one plant in Kent which already alleviates the waste burden from surrounding farms to dispose of manure, straw and fruit which was deemed unfit for sale, and converting these items into biogas, which then heats the surrounding houses, and electricity, which powers the plant in the first instance, with the surplus being exported to the grid. Now, if you were to scale things up, then a larger AD plant could power between 3,000 or 4,000 homes. You're talking the sort of market town size, and taking then a combination of food, waste, sewage, sludge, agricultural waste, all these kind of things from the surrounding area, that could then meet the town's requirements for biogas and energy, and would create a larger scale circular economy. Again, though, local communities are often against the construction of these plants, citing noise and disruption. So we'll have to see whether the true demand and need will outweigh the NIMBYism here and elsewhere. That hasn't, of course, stopped a number of planning applications, though. Only weeks ago, the press was lauding the number of projects applying for permission in Britain. And now this was probably not surprising, given the total had reached a 4-year high in the UK, representing a 75% increase on applications made 3 years ago. And it seemed that this trend really evidenced the appetite of both the public and energy suppliers for clean energy, and the growing enthusiasm for attaining our climate goals. More on that shortly. Now, whilst the delay between application submission and operational status remained a perennial challenge, clean energy was gaining momentum. Simultaneously, production costs of the technology was decreasing, and I think funders too were becoming more alive to the returns on their investments that were either potential or actual. The government also showed an increase in interest in stimulating the market, making an important concession in respect of onshore wind subsidies, a block on which was put in place some 5 years ago, something else we can thank David Cameron for. Fast forward to earlier this month, of course, and the International Energy Agency, or IEA, warned governments needed to robustly support the ongoing development of renewable energy in the face of the economic impact of COVID-19 and the oil price crash that I mentioned earlier. So where does that leave us now? Well, in scrutinizing the impact of coronavirus, the European Commission observed that closed borders risked interrupting product chains, with the disruption affecting a variety of areas, from energy technology all the way through to agriculture. Spokespeople for the Commission have been, perhaps understandably, vague as to the strategy for safeguarding clean energy investments, but we will need both clarity and action soon, though, as the renewable investment and energy efficiency at the very heart of the December 2019 European Green Deal, the aim of which is to achieve carbon neutrality by 2050. Now, of course, we've left the EU, and therefore our strategy remains unclear as to what we will adopt in respect of the Green Deal. Really, we've got three options. That's non-alignment with a lower ambition for climate and environmental standards, which would seem to be somewhat unambitious. Non-alignment with a greater ambition for climate and environmental standards, which is perhaps not very likely, or a policy mirroring. So it's going to be very, very interesting to see what happens there, given the boldly touted freedom from the legislative grasp of the EU that we've heard so much about, and we shall see which path we end up following. Now, the IEA also commented that in the shorter term, and as government creates and implements a stimulus plan to counter the threat of coronavirus, we need to ensure that clean energy investment doesn't get lost amidst the flurry of immediate priorities. And the IEA, in fact, recommends that governments increase support for renewable energy generation, the benefit of which would be twofold. both economic stimulation and the acceleration of the clean energy transition. So, which renewable technology might be most affected by the current pandemic? Well, people are suggesting that, of course, because of the manufacturing base for solar PV, that is going to bear the brunt of the effect in this field. But of course, the extent to which those temporary closures in China will affect this technology will soon become clear, no doubt. And time will tell the overall impact that COVID-19 has brought on the renewables market. That being said, Bloomberg's findings very recently that by 2050, half the world will be powered by wind and solar energy means that the market is certainly one to watch. Well, thank you very much. And we've got some time for some questions there, I think, as well. If there are any there.
Which is lucky, Laughlan, as we have a couple of questions you'll be glad to hear.
Yes, I'm bracing myself. Yes, okay.
Okay, first one. How about developments with hydrogen fuel cells?
Yeah, I mean, I think it's a fast developing area, and I think it could well be the subject for another talk, as I'd be loath to not do it justice now. And if that is something that we would all like to hear about, I'm happy to then produce something else on those lines. Yeah, but I feel it's probably a subject for a standalone number rather than discussion.
Okay, no problem. The second question is, Mike is curious to know about any advancements on storage for electricity and heat, either local to a building or as part of a major grid.
Again, I think let's put that in a second presentation. But if this is what people want to know about, let's do that in some detail rather than some observations.
Okay. No problem. If anyone has any other questions, let us know. Otherwise, we will bring an end to this. If you've got any questions for Laughlan directly, his email will be attached to the recording of this, which will be available from tomorrow. Please feel free to email him directly. I know he never minds that. CPD certificates will be sent out tomorrow, and next week we'll also be bringing out details of our June online seminar schedule. So if anyone's got any queries or you want to book up for that, let me know. If you're not on the newsletter distribution list, again, let me know. Other than that, thank you very much all for turning up tonight, and we look forward to seeing you again soon. As always, please stay safe. Thank you very much, everybody. Thanks, Laughlan. I'll speak to you outside of this later. Thank you.
Very good. Thanks, everyone. Cheers. Bye-bye.
Bye.